Alright, welcome back everybody. My name is Dustin. In the last video, we changed the batch renderer to use the new batcher template here. And in this video, we're going to actually start the new renderer class, which will have some draw functions and some wrappers for the OpenGL functions. So the first thing we're going to want to do is create the new renderer class. So let's close these. Go to our core, add new renderer.h. And then we're just going to give it a namespace, Scion rendering, and we'll have a class, and that's going to be our renderer. Cool. So let's make a couple of enum classes as well. If we take a look at the GL enable function, it takes in a GL enum for the capability. So there's various capabilities that we could use, but we're going to make a little enum class wrapper around these capabilities. The only one that we care about at the present moment is GL blend, and maybe the GL depth test and line smooth. So we'll add those three in for now, and then we'll add more in later. We're also going to be creating another enum, and that will help us for the GL blend function. So here, GL blend func, this takes in a factor, okay? So these are our blending factors, and there's different blending factors that you can have. GL source color, GL1 minus source color, stuff like that. So we're going to add in a little enum class for that as well. So we can go enum class, and then we'll call this GL capability. Capability. And it's going to be GLU int. Oh, let's include glad here. Cool. And we'll have one for blend. And that'll just be equal to GL blend. Then we'll have depth test. We don't really need depth test for us, but we'll put it anyway. Depth test. And then line smooth. GL lines. That's good for now. We'll add more in later as we need them. Okay, and let's create another one for the blending factors. Also, we'll say enums class blending factors GLU int, and we'll have 1 that's equal to GL1. There's 0 as well. Source alpha GL source alpha, and 1 minus source alpha. GL1 minus source alpha. And we'll add in more as necessary. But that's good for now. And these will be actually public. And then we'll have some private here. So now that we have those enums, we're going to need to be able to draw primitives like lines, rects, and circles. So let's go create a new file right now to hold the primitive definitions. So in here in our essentials, we'll make a new file. And this file is going to be called primitives. Primitives.h. And that'll also have a namespace Scion rendering. Scion rendering. So what are some primitives we're going to need? We're going to have a struct line. And we're going to have a struct, we'll say rect. And then we'll have a struct circle. Okay, let's include our vertex. So on our line, that will have 2 positions, GLM, vec2, P1. And we're just going to have these all start at 0 and P2. Because the line is basically just 2 points. Cool. And it's going to have a line width, float, line width. That'll start off at 1. And then a color. Just default color. Then we have a rect. A rect is going to have a position. And it's going to have a width. float, width, height, and it's also going to have a color. And then a circle will also have a position. It will have a line thickness, or just a thickness. Where 1 is 100%, and the smaller the thickness, the thinner the kind of like a donut shape is. And they also have a radius. We'll just start that off at 0 for now. And a color. Okay, so there's some of our primitives to start out with. Let's go back to render. So let's include our primitives here. So include primitives. That will be in the essentials. Primitives. And let's also include our batch renderer. And down here in our private, we're going to have a few things. We're going to have a vector of lines, std vector. That's going to be our line. We'll say m lines. And we're going to have a vector of recs. And a vector of circles. And we'll say m circles. Okay. Then we're also going to have some unique pointers of batch renderers. So we're going to have a line batch renderer eventually. We'll call it MP line batch. And then we're going to have another batch renderer. And this one is going to be our circle batch. I want to say circle batch renderer. Circle batch. MP circle batch. And then we'll have another one for sprites if we want to draw sprites, but these will be more like a default. This one could be sprite batch renderer. And we'll just call this the sprite batch. Cool. And we can comment the circle one out today because we won't be able to get to that. But the goal is to get the line batch renderer actually drawing. Okay. So now that we have our private variables that we're going to need, let's start making some public. So we have our constructor. That's just the renderer. We're going to have a default destructor. So what are some OpenGL functions that we're going to wrap? We're going to wrap the set clear color, so void set clear color. That's going to take in GL floats. Red. GL float has lowercase. Red. Green. Blue and alpha. Cool. And we're going to have clear buffers, void clear buffers. And then we're going to have some bool, clear the color buffer. That'll default to true. Bool depth. That'll equal true as well. I don't think we're going to be using stencil. We'll put it in as well. Probably not going to be using it. Bool stencil equal to false. All right. And then we'll have a void set blend capability. That'll take in our blending factors. That's our S factor. This is basically just a wrapper around GL blend func. This will take another one. Blending factor. This is D factor. We'll have another one for set with viewport. So void set viewport. GL int x, GL int y. GL size I width, GL size I height. Beautiful. So that was our GL wrapper. So now we have some draw functions. So basically we'll just say some OpenGL render function wrappers. Cool. And now here, let's have some draw calls. So draw call. Let's say primitives. Primitive draw calls. Cool. So the first one is going to be draw rect, or we'll draw a line first. Void draw line. And we're going to have a const line reference line. And we'll have another one, draw a line, but this one will take in the two positions. So what does a line consist of again? This of const glm vec2 reference p1 const glm vec2 reference p2, then the color const color reference color, and then we'll have the line width, so float line width, that'll equal to 1.f by default. Cool. So we're going to do the same thing, but for recs. Just to draw a rect. And then this will just take in a rect. 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 This only has one position, but then it's going to have a float width, float height, and color. And this will be position. Awesome. We're also going to be able to draw filled recs as well. So we'll put that here. Draw filled recs. We probably won't be able to get to that today. And we're going to have void draw circle. And that's going to take in a const circle reference circle. And we'll do it again with its position. Const glm vec2 reference position. Sorry. Position. It's going to need the radius. And it's also going to need the color. And it's going to need the thickness. So float, we could say line thickness, or we'll just say thickness. Yeah, that makes more sense. Cool. And the thickness will also equal to 1.f. That will make it a default to a filled circle. Okay. And then down here, we're going to actually have the draw lines function. This will actually be the call that actually does the drawing. So void draw lines doesn't take anything. Void draw recs. Void draw filled recs. And void draw circles. And then void clear renderer. Say clear primitives. Cool. All right, so we got a lot of functions to do here. Okay, and we got this line batch render to do. So we have all these functions. Let's just make all these first in our render.cpp. Cool, those should all be made for us. Let's go to render.cpp and just quickly change this. All right, so we got this error here. That's because of our line batches here. So let's actually go do this right now. So line batch render is what we want to create. So come here in our core, add new item, LineBatchRenderer.h. And here we're going to include our batcher. We're going to include our batch types. Whoops, not primitives. But we can have the primitives as well and the batch types. Batch types. Cool. Name, space, Scion rendering, class, LineBatcher. Public batcher. So now that we have our batcher, remember this takes two template parameters, and those template parameters are going to be the line batch and the line glyph. So let's go back to it here, and we're just going to add them into this file here. Okay, so in the struct line batch is just a struct line batch, and all that is GL uint offset, and it's going to have an offset of 2, and then a num vertices. That's going to be 0, and the line width. Float line width. Now the GL set line width is a global function, and when you set it, it's supposed to set it for all lines. So I'm having a problem changing all the lines to have different sizes, but we'll worry about that later. Today we'll just worry about getting the lines drawn onto the screen. Okay, so and then down here under glyphs, we're gonna have the line glyph. So struct line glyph. And a line glyph, that is totally spelled wrong, is just a vertex with 2 points, P1, P2, and then it's going to have a float line width, but again, line width isn't working the way I want it to at the moment, but that's okay. We'll leave it as is. So let's go back into our LineBatchRenderer here, and our line batch, and then line glyph. Cool. So let's go back here, and let's include our LineBatchRenderer. All right. So see, that's real now, and we have these two, line batch and sprite batch, and we might as well do those. MP line batch, and we'll just make that to null pointer for now. MP sprite batch, that'll also be null pointer. Cool. And we'll set those inside of the constructor. So let's go finish the line batch renderer. All right, so we're gonna have our private, and we're gonna have our public. And the private, we're gonna have the generate batches, virtual void generate batches. That's going to be an override. And then we're going to have our initialize, void initialize. Cool. And we're going to have our constructor, LineBatchRenderer. Destructor can be default. And we're going to have our two overrides here. So virtual void end override virtual void render override, and then void add line. And the add line will just take a const line reference line. Cool. All right, let's create all of that. Let's open up our LineBatchRenderer.cpp. Cool. So the first thing in the constructor, we're going to want to just initialize the batcher. And the line batch does not need the indices. Remember before, if we go back to the batcher here, if we were using the IBO, we want to set that to true, but we're not using the IBO for this. We'll just be using vertices. Okay, so let's go back here. And we also want to call our initialize inside of it. Cool. So let's go to the initialize function. So we're just setting two vertex attributes here. Set vertex attribute 0, 2, GL float, size of vertex, then our stride, void pointer, offset of vertex, vertex, and position. Cool. And then one more. And this one's for color, and you have to remember this one is transposed, so we have to use GL true there. Change this to color. Change this to GL unsigned byte. Unsigned. That's probably easier just to write. Unsigned byte. And this is 4 and position 1, or layout position 1. Cool. That's it for that. In our end function, we don't really care about layers for lines because lines are usually just being used for debug purposes. Like say when we want to draw a ray for ray tracing or lighting and stuff like that, we need to make rays. Well, that's what we're going to use it for. We're not going to really use it for anything real. So we go if, just see if the glyphs are empty. And if so, just return. There's no need to go into the generate glyphs function if we have no glyphs to generate. Okay? Or generate batches, sorry. Generate batches. Inside of our render, for const auto reference batch in m batches, GL draw arrays. This one is GL lines. We were using GL triangles before, but we want to do lines for this one. And then 0, and then batch num vertices. Cool. All right. But before we go, we have to enable our VAO and disable our VAO here. And we also want to set our lines to smooth. GL enable GL line smooth. I know we're setting the renderer to be able to do this, but we're just going to put this here for now and then just disable it here. Cool. So there's our render function. The add line function is pretty straightforward. We're just making a shared pointer to a line glyph. And we're going to call it new glyph is equal to std make shared line glyph. So let's just create a line glyph and we'll set it all here. New glyph dot line width is equal to line dot line width. New glyph dot p1 dot position is equal to line dot p1. New glyph p1 dot color is equal to line dot color. And we'll do the same for p2. So let's just copy this. We don't need a line width because it's the same. Change these to p2. Change this to p2. Cool. All right, and then we can just push it into our glyphs. M glyphs dot push back std move our new glyph. Cool. All right. So now we just have to go to our generate batch function, and it's pretty similar. So let's go to our other batch renderer here and just copy all of this, and we'll change it accordingly. Go here, paste that in. All right. So this is not going to be that anymore. It's going to be 2. And we don't need any of that. Change that to line. Let's get rid of all of this. Keep these. Get rid of this. We're only going to need 2. Change this to line. That's P1 and P2. Okay. And then batches dot back line width is equal to line dot line width. Cool. And then right here, let's get rid of all of this and say if there's only one glyph, we're just going to break. Else, we're just going to batches dot back and we're going to take our num vertices plus equals 2. All right, I think that's all we're going to need. Get VBO size. Cool, that looks good to me. And if it doesn't work, we'll come back and see what we did wrong. Okay, so that's our line batch render. So quickly, let's go back into our render.cp and get some lines going. So we'll just do these 2 draw line functions real fast. And these are just m.lines.pushback line. Copy this. Pushback, and this one we're just going to create a new line .p1. Set in the wrong order. Must be. Cool. All right. Let's actually not forget that we have to make np line batch is equal to std make unique line batch renderer. Cool. We might as well do the sprite batch as well. All right. And we'll do our drawing lines all in here. So the draw lines, actually, we're going to need to change this a little bit. So we're going to need to take a shader, reference, and we'll take the shader. And then we need the camera as well. Camera 2D, reference, camera. Cool. So let's copy these here. Go back to our draw lines function. Put that in. And this we'll put class. Go back into here, go up to the top, let's include our shader. And let's include our camera. Cool. And go down. Let's do our draw lines. So we go auto. Let's get the camera matrix. Cam map is equal to camera.get camera matrix. We want to enable the shader. Then we want to set our uniform projection. So shader, set uniform, map 4, projection. And we need to begin our line batch. Then go through all of our lines. For const, auto, reference line, in lines, np, line batch, add line. Cool. And our line batch. Render it. And disable our shader. All right. All right, now that we have that, we have our very basic. There's lots of functions we still have to fill out, but let's go add this into our editor here, into our registry. So let's go to our application, go to the application, editor, source, application. Down here, where do we have rendering anywhere? Yeah, right here. So let's add this in, add in our renderer. So we have a renderer in, and down here, so this is what I want to eventually replace, these here. This is what we'll create our renderer. So we'll go auto, renderer, so you can do std, make, shared, Scion, rendering, renderer. And let's actually add it to the registry before we do anything else. So right here we created our registry. Let's add our renderer to the registry. So add to context. Here we want to go renderer. It's going to take in our renderer. Cool. Failed to add the renderer to the registry context. So now we have the renderer in the registry context, so we can grab it when we need it. Okay. And then right here, before true, let's actually add a new line. Okay. So we'll say renderer, add line, or not add line, draw a line. And that's just going to take in a line. And the line takes in 2 points, so it's going to be GLM, vec2, and let's put it at 50.f, GLM, vec2, 200.f. Let's do it this way so we know we're doing P1 is equal to dot P2 is equal to, and then dot color is equal to, let's say, Scion rendering color. And let's make this red. Cool. So we're drawing our line. So we're basically just adding in them. Okay. And then let's go down here. And right here, we need to get our renderer. So let's just copy this line. Renderer, context, Scion, rendering, renderer. So we got our renderer, and down here we can say renderer draw lines. Cool. Now we need a shader for this and the camera. So we can get the camera right away. We should have a camera. Scion rendering camera 2D. I believe we made the camera. If not, it'll fail and we'll fix that. And we'll send the camera in. We'll get to that in a second. But we do need a shader. So we'll have to go auto. We're going to need to get the asset manager. So we go auto reference asset manager is equal to MP registry get context std shared pointer, asset manager, but that is in Scion resources, asset manager. So we need to get the asset manager, and then we need to get the shader. So we can go auto reference shader is equal to asset manager get shader, and it needs the shader string name. So we need to put that in there. Okay. And we're going to call it color. I'm going to make one and we're just going to call it color. It's going to be a very basic here. Non-const. So we're sending a const. No, we're sending a shared pointer. Let's do this here. Cool. So we're just going to call the shader name color. Let's go make that shader quickly now. Here we'll go into our shaders and we'll create another one. Add new. And we're just going to call this the color shader. So color shader dot vert. And we'll make another one. Add new. Color shader dot frag. Cool. In our color shader, we're going to be version 450, layout, location is equal to 0. And that's going to be an in vec2 vertex position. Layout, location is equal to 1. In vec2 vertex color. We're going to have two outs. So out vec4. That's going to be a fragment color. And out vec4 or vec2, sorry. That's the fragment position. Void main gl position dot xy is equal to projection. Oh yeah, sorry. We need that as the uniform. That's a map4 projection. Cool. Times vec4 vertex position 0.0 1.0 dot xy gl position dot z is equal to 0.0. I probably don't have to do all this weird stuff. Put that here. GL position dot w is equal to 1.0. Cool. Then our fragment color is equal to our vertex color. And our fragment position is equal to our vertex position. I'm not even sure we need that. But that's fine. Let's continue. Yeah, we don't even really need the vertex position. But we'll leave it for now. And we'll go version 450 in vec4 fragment color vec2 fragment position out vec4 color void main and then color to fragment. Okay. So we don't need this here. Let's get rid of that. So we just very simple shader here. If we do need it, I'll put it back. So let's just get rid of this now. Cool. Out fragment position. No. Cool. All right. Very simple shader. Should work for us. Now let's go back into our application and add this shader in. We're going to call it color shader. So we need our shader and our camera. These are both shared pointers, so we need to dereference them. Okay. And up here where we add our shaders, load shaders, let's actually just copy all this here. So we have our basic shader first, and we'll have another one and just call it color. And we just called it color shader. Cool. Failed to add the color shader. Failed to add the basic shader. All right. And I think that will work. What's the worst that could happen? Let's run it. All right, so we got a fail here. Unexpected error in shaders.vert. Let's run it again. Ah, yes. Silly me. So this had 2 brackets here, but only 1 closing bracket. Cool. Okay, still have an issue. Yep, GL position. This here. Sorry. Okay, incompatible types. Silly. You guys probably caught all those mistakes already. That's fine. Bang. Okay, so we have an issue here. So M batches was null pointer. Let's check our call stack. Application render, draw lines. So yeah, there's a problem here. I'm trying to go back, but there's nothing here. I didn't push anything in yet, so I actually need to go back. That's my fault. Sorry guys. So we actually have to go M batches dot pushback std make shared line batch. Cool. Now that should work for us. We're assuming that there's 1 here. Well, if it got here, it has to have at least 1. Awesome. See our line? Perfect. That beautiful red line. Let's actually not load this map so you can see the line better. So we'll go into our editor and we have that in our scripts, test project. Actually, that would be in main. We can just stop it in main here. We just won't load anything. Let's do this. Comment those out. And now we should just draw the line for us. Awesome. Perfect. See, we have this beautiful red line here. Okay. All right, so that's enough for this video. This video is taking a long time to do. It's been about almost an hour, so probably about 45 minutes after I'm done editing. Now that you know how to draw a line and we got our batch renderer and we've gone through how to create a new batch renderer here, why don't you look at the renderer functions here and try to fill out these functions yourself. So the set clear function is just a wrapper around GL clear color. And then this one is the same with clear buffers. Try to clear the buffers, the GL clear buffer. So if we go into our application.cpp, that's just this here, which GL clear, so clear buffer bit, color buffer. Try to clear these buffers, clear the color, set viewport, do all these wrappers inside of the renderer. That's going to be a little challenge for you guys for the next video. Set blend capabilities, do these things. So it's the blending factors here. Just take another look at this here. So it's just the blend function, right? That's all you're doing is doing wrappers for these blend functions, okay? And then try your best to do a draw rect, not draw fill rect. Draw filled rect we'll handle ourselves in the next few videos, but try to do the draw rect. The draw rect is just going to be 4 separate lines. So you can just do these functions where you're calling, where you're pushing back lines, and you're just drawing 4 lines. You don't even have to push back lines, just call these functions inside of these 2 draw rect functions and see if you get a rect on the screen, and just add it in your application and see if you can actually get it going. Okay, so take a crack at it yourselves, see if you can do it, and do a little thing to clear them here. Also, if you're feeling even more confident in your abilities, try to bind the renderer so you can make these draw calls in Lua. So we already have a renderer that we added into our registry. So just go in here to your core and your scripting and add in see how we did the sound bindings? Add one in for the renderer. And then try to do all the draw calls using Lua yourself. See if you can do those. If not, I'll try to do it in the next video. Okay, take it easy.